So Bob and Carolyn work at a marketing agency, and they're supposed to have good ideas for the marketing agency. Bob has a 60% chance of having a great idea on any given day. So I'm going to say that event B is the event of Bob having a great idea on that given day. And C will be the event that Carolyn has a great idea. So again, we're told that these two events are independent. So whether he has a good idea won't affect her, and vice versa. Perfect. So that being said, we know that PB times PC is equal to PB and C. And this will only work because they're independent events, and we were told so. So Bob has a 60% chance, so write 0.6 here, of having a good idea. And Carolyn has a 70% chance of having a good idea. 0.6 times 0.7 is 0.42. So we're going to put that right in the middle here. Actually, I'll write it as 42%. I hope nobody gets offended by that. Great, so that's the overlap. That's the probability that both have good ideas in any given day. So that answers our first question. 42%. That's not a bad thing. Both have great ideas. Wonderful. Okay, but question B is asking, only Carolyn. What is the probability that only Carolyn has a good idea but not Bob? So we're looking for the number that goes in here. Okay, so we know. Oh, sorry. This is what we're looking for, because I thought for a second that Carolyn was here. No. Carolyn's here. So we want to find out the probability that only Carolyn has a good idea, but not Bob. And she has a 70% chance of having a good idea. So 70% minus 42 is just 28. There's a 28% chance that Carolyn will have a good idea, but Bob won't in any given day. So that was the probability of Carolyn having a good idea and Bob not having a good idea. Okay, but let's also calculate the chance that, or the probability that Bob is the only one with a good idea or a great idea. And there's a 60% chance that Bob will have that idea. 60% minus 42, 18% chance that he will have one, but Carolyn won't. And finally, let's calculate what's outside here as well, because that could be helpful in some questions, right? And I will just add up all these guys to see what we get. So 18 plus 42%, that would be 60%. 60% plus 28 would give us 88%. And that's short of 100% by 12. So that's what goes outside right here. So there's a 12% chance that neither of them have great ideas on any given day. But we're looking for the probability that only one of the two, but not both, will have a good idea. What will we choose here to represent that? This and that. This is out because this represents both of them having a good idea. So I'm going to go for P, B, or C minus P, B, and C. So the probability that at least one of them will have a good idea is 88%, minus the probability that both of them do. 88 minus 42, 46% chance. That exactly one, but not both, will have a good idea. That's it.